All right, now with this limit at infinity, we plug in the x equals negative infinity like it's a number. The result is going to be negative infinity over infinity, which is sort of strange, demanding a specific technique. Before we get into that technique, we're going to explore why this counterintuitive result even shows up at all. This is particularly strange when you think about the algebra in here, plugging in the negative infinity and squaring it, and then multiplying by 2, you're going to see a plus infinity here, and then you plug in the negative infinity into that 9x, and you see a minus infinity minus 7. And sort of an obvious question is, why don't those cancel out? And the short answer is because infinity is not a number. Infinity minus infinity could be anything. Infinity divided by infinity could be anything, including infinity. So we have to handle this more carefully. So in general, we're looking at something like 2x squared plus 9x minus 7, and what happens if we stick in an infinity. There's sort of two approaches to analyzing a polynomial. One way of looking at this is more intuitive but not mathematically careful, and that is to think about polynomials as things that can be factored. So this 2x squared plus 9x minus 7 in principle should be factored into something like x minus c1, x minus c2. We don't actually need the c1 and the c2 for this discussion. If you plug in the minus infinity for the x, now, the numbers c1 and c2, they really are just numbers. So you're going to see 2 times negative infinity minus some number times negative infinity minus some number. And when you subtract a number, even if you add a number to negative infinity, it's not enough. The result is negative infinity, and that's in both spots. And then you're going to double that. And really, doubling infinity doesn't do anything. It's still infinite. So this is going to be 2 times the negatives become positive, and that squares it. And then positive infinity squared is positive infinity times 2 is positive infinity. This is sort of the more intuitive way to look at it. And you can see here it is not the negative 7 that you might have anticipated. The infinities did not cancel. Again, this is a quadratic. We don't have to factor it to find the precise details, but we can take that it is factorable, and then there's some numbers. And when we plug in the infinity, those numbers can't compensate, and we're just left with a bunch of infinities multiplied together. Same thing happens with the cube that's in the numerator. In principle, we should see something like this without knowing what the c1, c2, and c3 are. Once we plug in the negative infinity, you can see here that we get 4 times negative infinity cubed, which is negative infinity. So that explains the numerator and the denominator somewhat intuitively, but not mathematically careful enough, because those numbers inside the factors, the c1, the c2, c3, could be imaginary numbers, and then this opens a whole can of worms. So intuitively, I think this is pretty easy to follow the gist of the idea. Even with the imaginary numbers, an argument can be made. The more precise reason why the infinity minus infinity doesn't cancel out, just leave the minus 7, is that we can actually take that polynomial, any polynomial, and we can write it in a very strange way that might not seem like it's a good idea at first, but we can do it. We're going to write 2x plus 9, factor out an x from the first two terms, and then minus 7. And now, if we FOIL out, then we see the 2x squared plus 9x minus 7. It gets us back there, so we did do it correctly. Now, when we plug in the negative infinity in for x, then you can see 2 times negative infinity plus 9 times negative infinity minus 7. And the negative infinity times 2 is negative infinity. Add 9 is still negative infinity, so it's negative infinity times negative infinity minus 7, which is plus infinity minus 7, which is plus infinity. Now, this is still not perfect mathematically, because you can't just plug in infinity and do arithmetic with it. However, since all of these operations that we're working with infinity as though it were a number, all of these operations just involve arithmetic where we're mixing infinity with constants. The only time the infinities are mixing together is when they're being multiplied. So if we do this with the numerator, we could very carefully write this as 4x squared plus 3x minus 5. Now when we stick in the minus infinity for the x, we see 4 times minus infinity squared plus 3 inside minus infinity outside minus 5. Now the minus infinity squared is positive infinity, and you're doing 4 times that plus 3 is positive infinity times negative infinity minus 5. Positive infinity times negative infinity is negative infinity. Subtract 5, that's meaningless, so you just end up with negative infinity. So again, there's two ways to handle the reasoning behind this fraction up here, like where that comes from, that accounts for this strange thing that you might expect to happen, but that does not actually happen. The short story of this is the only reliable arithmetic for infinities is multiplying them. So if you're not multiplying them, you're going to have to be more careful and more precise. Even the work that I have here is not the most precise. Mathematically, you should be taking greater care, but any polynomial can be rewritten in a structure like this. And so now we will get to the calculus technique.